So now we will discuss how to solve problems. The first thing is drawing free body diagram. FBD we call it short. Suppose there is an object A and it's connected to an object B. An object B is connected to an object C. This is the system given to us, three objects. Now, the first rule is that whenever there are multiple objects in any system and we have to solve Newton's equation, the Newton's equation will be ultimately to find out that what is the acceleration of A, acceleration of B, acceleration of C, or what is the force existing between B and C, between A and B, and between A and C. Ultimately, all the questions will be of this type. So there will be two cases generally. The one case will be that the system is at equilibrium, or a few objects of the system are at equilibrium, or the entire system is unstable, not in equilibrium. So whenever there is word equilibrium, equilibrium means F net 0. Suppose I say that this object A is at equilibrium. It means all the force acting on A, they result into 0. It means force AB, force AC, summation adds up to 0. Now the important point to note here is that this force AB is the force acting on A from B. Then from Newton's third law, there will be definitely a force BA, and force BA will be equal to minus of force AB, and magnitude wise both will be same. It's clear from Newton's third law. So this will be force acting on B from A, and similarly AC is the force acting on A from C, and there will be a force CA that will be acting on C from A. Now you can see here that when we focus on this object A, then we have to see only those forces which are acting on A, and we have to forget all the forces which A is acting anywhere else. First thing is focus on one object at one time, and then find forces acting on that object. At the time, we have to forget forces which that body is applying on other objects. So that is it. If we consider these 3 points, we are not going to face any problem in solving anything. So here we first focus on this object A, then we note down all the forces which are being applied on A. So just there are two objects B and C. So these are just two sources of force. So that one force will be force AB, another is force AC. So this is our net force. Force net. Now if it is given, suppose that object A is at equilibrium. So equilibrium means net force 0. So that will be written as 0. Maybe it not be clear from there. So F net is 0 if acceleration object will be also be 0, and this will be the case for equilibrium. And suppose it is given that object C is moving. So what we will do? We will write all the forces acting on C. So the sources of force are from the object A and object B. So the first force will be force CA plus force CB, and that will be equal to, using Newton's second law here, mass of C into acceleration of C. And similarly we will apply the same thing on object B. For object B we will write force BA plus force BC. That will be equal to mass of object B into acceleration of object B. So just we have to keep this thing in mind, that first do not get confused with different objects on any system. So first focus on one of the object. Just try to find out that how many forces are acting on that object. That moment, forget all other things. Just see how many forces are being applied on that particular object. Then apply Newton's second law, write in the Newton's equation, F net is equal to mass into acceleration, and that will be your one equation. So as it is a three-body system, there are three equations. In class 9th and 10th we have studied how to solve multiple equations simultaneously. So whenever there will be three equations, then there will be three variables. If there will be two equations, there will be two variables, and the rest life is very easy. We have to just solve out the numerical equations. So now we will solve a real problem. And before solving that, I would like to mention one more point here, that we have to not forget that force is a vector quantity. So if there is any object A, one force is acting here, F1, one force is acting here, F2, one force is acting here, F3, and maybe one force is acting here, F4. So if the forces are not in one line, then we have to take into consideration forces along X and forces along Y. So it's very obvious that if it's a vector quantity, so we have to take, suppose this is the angle theta, so we have to write first for the X axis. We write F1 plus F2 cos theta minus F4. It's very obvious, it's just 180 degree opposite, and that will be equal to mass of object A into acceleration of object along X. For Y axis, we will write F3 plus F2 sin theta. Just if we have already resolved it into axis, we can just take the magnitude. So that will be equal to m of A into acceleration along Y. So from these two equations, you will get Ax, and this as we will get Ay, and then we will write the net A is equal to root under Ax square plus Ay square. From there we can also find out the angle at which it will effectively move. So that will be theta equal to tan inverse Ay by Ax. These are simple vector calculations. being pulled by a man. So this will be the direction of force. The mass of the object is m and this angle is theta. So we have to find out what will be the acceleration, and this is ground. So what will be the acceleration of object A? So one thing is pretty obvious, that this is ground, man is pulling the object along this rope, this standard string. So object A is not going to lift up. It may, but it is given that in the question that it's not going to lift up right now. So it means we will write directly that acceleration along y is going to be 0. It's given that he's actually trying to pull it, not to pull it upwards. He's just trying to pull it horizontally at this angle. So there's given that the object is not going to lift up. So acceleration of object along y will be 0. So this acceleration ay is 0. So we have to only consider the acceleration along x. Now, as we discussed in the previous lecture, that this man will apply force F here, and that will be equal to the tension along the rope. So suppose this the tension T along the rope, so that is acting on object at an angle theta. At the same time, you can see that there is a contact here. So it means there will be a normal force N. At the same time, there will be a gravitational force mg. So what we will do? We have to write equation, Newton's equation for this object. So first we write along x-axis F. So what we will write? We will write T cos theta. There is no other force along x-axis. This is the gravity here. This is the normal here. This is the only force. So T cos theta will be mass into acceleration along x. For the y-axis, we will write normal, because these are coordinate system. You have to also keep in mind that what is our plus and what is our minus. So we are taking this as plus, this as plus. So you will write here n minus mg plus the y component of t. So plus t sin theta. And it's already said that this object is not going to lift up. It means the net acceleration along y-axis will be 0. So this is going to be 0. So this is our one equation. This is our another equation. And it's given that the T is just equal to the force being applied from man along the string. So this P is given, this theta is given, this mass is given. So we are left with just two variables, n and ax. This turned out to be system of two linear equations. We'll just solve it by putting the value, whatever given it is, and we can just make out. So this is as simple as this, that ultimately we have to resolve it along the x or y axis. This was a simple question as it was having just one body. We have to just resolve the forces along x or y axis, and we have to find out the variables. Now suppose our question is this. This is M1 and this is M2. And this is a fixed wedge. And the string is moving around a pulley. Now when there is pulley, so I think I should discuss properties of pulley. The pulley which we are considering here, or in most of the problem, if not mentioned, then what are the assumptions we have to take into consideration? The first one is that pulley is not going to apply any friction force. No friction force on a string. So ultimately it will be a smooth pulley. And also pulley is massless. So ultimately it turned out to be a continuous string starting from this object, passing over the pulley and coming from this object. So as we discussed when we were discussing about tension, that on this object M1 and this object M2. So first focus on one object, M1. What are the forces acting on it? Definitely gravity, M1G. Tension away from the object, this is the tension. For object M2, what are the forces? The forces are normal force applied from base. We have discussed elaborately on normal force in the friction part, but still for the time being I would just like to remind that whenever there are two objects in contact, then there is a force comes into play which is perpendicular to the surface of contact. As we can make it out here that this was the wedge and this is the object M2 and this is the surface of contact. So the normal force the wedge will apply on the object will be along this direction. And as per Newton's third law, this object will also apply opposite force of the same magnitude on the wedge. But again a reminder I am putting that we have to forget all the forces which that body applies on any other object. So for the time being we will just forget that part, what the force this object is applying on wedge. We have to just consider what are the forces being applied on this object. So this is one of force normal, and obviously away from the object, because object has tendency to move down. So away from the object, this is the tension T. So there are basically forces in two components along in the plane. So it's better we take into consideration x and y axis. So this is the gravity mg. So if we consider the y axis, so on M2 mg is acting, and at the same time this is a component of normal. But this picture becomes a bit complex. So what we do, instead of resolving into this x and y format, we better resolve it along this axis and this axis, because then things become even more simpler, because ultimately the angle between these two is 90 degree. This is a coordinate system, an orthogonal coordinate system having 90 degree angle in between them. So this is x dash or y dash. So we have to just resolve mg here. So this is the angle given theta. So if it is theta, this will be 90. This will be 90 minus theta. It means this will be your theta. So this will be your mg cos theta, and along this will be mg sin theta. So you can rub this part. For the object M2, forces are along mg cos theta and normal, and then T and mg sin theta. Now it's being asked that if say the system is in equilibrium, so if it is given that system is in equilibrium, then it means that all the objects which are part of the system, they are at equilibrium. It means M1 is not coming down, M2 is also fixed, and it's very pretty obvious that if M1 is fixed, M2 has to be fixed, because again one assumption that the string length is not going to change. So if it's one end of the string is fixed, another end has to be fixed. So in the question it may be given in another one form that M1 is fixed. So you have to make it out from there that if M1 is fixed, M2 has to be fixed. So this is just the way of writing questions in different forms. one form can be the entire system is at rest. So from there you will make it out easily that M1 and M2 both will be at rest. In another form it can be given that M1 is fixed. So if it is given M1 is fixed, then one of our assumption is that string length is not going to change. So if string length is not going to change, then M2 has to be fixed also. So from this given equation values, we will make it out easily. We can write one equation along this axis. So what will be that? T minus mg m2g sin theta. T minus m2g sin theta. That will be equal to 0. And also this is not going to move in this way. So n will be equal to m2g cos theta. Or m minus m2g cos theta. That will be equal to 0. At the same time, t will be equal to m1g. Or t minus m1g will be equal to 0. Now, there are three equations. So for the entire system to be at rest, this is the equation, and there are three variables. We don't know what is the t, we don't know what is the normal, and we don't know what is the theta. So the question can be framed in this form, that find the angle of the wedge for which this system having objects m1 and m2 of the masses m1 and m2, they are at rest. So this will be our approach. We will take into consideration these parts to be 0. We will just write the equations and then we can solve it easily. So what we did, we just wrote this equation for object m1 and we wrote these two equations for object m2 because they were system of forces acting along different directions. So in every problem for pair onwards, we will apply the same approach. There is nothing different. We have to take into consideration all the assumptions we have taken for pulley and for string, unless it is not being specified specifically in any problem, and then we can solve it out easily. So we will go into more problems in our subsequent session.